Hello, and welcome to this OpenTopography video. My name is Chelsea Scott, and in this video, I'll be discussing global bathymetry. And in particular, what is bathymetry? So bathymetry is the depth of water in ocean, seas, lakes, and rivers, and essentially gives us a measure of the topography underwater. As an example, here you can see the bathymetry just off the coast of the southern US. Here you have Houston and New Orleans. And this area here is a map of the bathymetry along with a hillshade of that bathymetry. And in blue is the deeper area. And then in brown to white are the more shallow areas. So you can get bathymetry data on OpenTopography. You'll want to come and select a region surrounding an ocean, and then you'll be presented with a variety of options, including the three that you can see here. And you'll want to select the global bathymetry and topography at 15 arcsecond, SRTM 15 plus version 2.5.5. Or of course, if this is updated, you'll want to add in and look at the newest version. And when you select that, you'll get this page, which gives you a little bit more information about the data set, in particular, including the 500-meter resolution of the data. And this data can be referenced from the paper here by Tozer et al. And the next few slides I'll be discussing come from the information directly presented in this publication. So why does bathymetry matter? So bathymetry impacts ocean circulation and mixing, and this in turn impacts climate, biodiversity, and food resources. Bathymetry also impacts geochemical budgets that are used in climate modeling to understand the heat and carbon capacity of the oceans. Bathymetry was critical for the discovery of plate tectonic theory. And finally, bathymetry is used in a variety of other applications, including modeling tsunami propagation, infrastructure engineering, and planning cruises. Here's an example of bathymetry off the coast of Alaska. Here we can see the trench of the subduction zone, and then some of the Aleutian Islands with volcanoes. So the SRTM 15 plus version 2.0 was derived from a variety of data sets. This data set is 15 arcseconds, so at the equator, that's going to have a pixel size of 500 meters. And data sets that went into this data set compilation include seaboard soundings, collected around on 11% of the ocean floor, shipboard-derived bathymetry at that 500 meter or 15 arcsecond resolution, jamstack bathymetry, which in particular collected high-resolution data off the coast of Japan, Geoscience Australia, which collected data in search for the Malaysian Airlines Flight 370, Southwest Iberian Margin, which collected data at a 100-meter resolution, the CCOM and SIO that collected data to image the Mendocino fracture zone. And then the rest of the bathymetries were collected by satellite-derived marine free air gravity anomalies, and this is collected at about a 6-kilometer resolution. We'll now be looking at examples of this bathymetric data set. First, we'll be looking at the subduction zone in South America. So here we are in northern Chile, and this is where the Nazca plate is subducting under the South American plate. And we can use this bathymetric and then also topographic data set to get an image of the topography along the entire subduction zone, which is what you can see here. And then here is a topographic profile showing that, where we have elevation versus distance in degrees. And in particular, here we see a seamount. Here we see the trench, which is at depths of about 800 meters. And that's this long linear blue feature that you see here. Then here we become on land, and we see this steep topographic relief area here. And this area is the forearc of the subduction zone. And then here we have the volcanic arc. And the next example, we'll be looking at a mid-ocean ridge. And this is at the plate boundary between the North American plate and the Eurasian plate. Geographically, we are between Florida and Morocco. So here we have the bathymetry of the mid-ocean ridge. And in particular, we see the mid-ocean ridge here. And then the mid-ocean ridge steps along a fracture zone. And then it continues here. And we'll look at a topographic profile along this red line. And that's shown here with elevation versus distance in degrees. And this is where the mid-ocean ridge is. And we can see relief of about 2,000 meters right here. Our last example is looking at the Congo Canyon. And this is in Africa at the Democratic Republic of Congo. And this feature starts as an estuary on land and then goes off land as a submarine canyon. And you can see the topography associated, or it's the bathymetry associated with this canyon here, with the deeper parts in the canyon center. And this is a profile at approximately this location, looking at elevation versus distance in degrees. And we can see that the width of the canyon is about 0.1 degrees. And since we're near the equator, this is going to be approximately 10 kilometers. Thank you for watching this video.